Hello, my name is Mayday, and this is my encoded quad bulk slice. Obi and Hamter have put together a better one, which will be used for Chronos main storage v3. Mine is bigger and less dense, but this allows for some of the functions to be shown a little easier. This is the layout we are using. We have direct comparator readouts from each chest, and we are using the minimum amount of hoppers, 2.5 hoppers per item and 10 hoppers per slice, counting the empty box collection hoppers. The slice will be full locked. Over here is the slice itself. Like I mentioned, it is not as dense as possible. Further, it uses extra droppers uh, as latches for in-slice logic, which is not ideal. The top box display in the blue terracotta was designed by Hemter and is globally locked. The bottom box display in the light blue terracotta was designed by Obi. These empty box collection hoppers do not need to be unlocked for either display to be used. The fence gate on the top hopper is to increase the reliability of empty box collection from the top display. However, it's not perfect. Boxes can still end up in the player area or on top of the bottom box display. On this side, we have the required inputs and outputs for this slice. First, we have rail lines, which alert the control logic when a display chest, has been emptied. We also have global locking, which can be turned on or off when a display is used. We also have dropper lines to deliver the requested items into the specific slice. These items come from an external bulk from which we call using a code. And this is done to reduce client lag when a player is in the main storage, and further server lag can be reduced by only loading the external bulk when required. Now we can move on to the restocking logic. We'll focus on the upper half of the slice, but the same logic applies to the lower half. For an overview, a signal is sent through the slices. This signal switches the state of the dropper latch for any empty slices. This triggers a dropper in the list dropper line. When this list dropper line is powered, the index item will end up in this powered dropper, which will send the code as well as reset the dropper latch. It also depowers this piston, which unlocks the hopper, allowing requested items to be sent and delivered to the slice. Once the request is completed or sufficient time has passed, the list dropper line will increment to the next empty slice or to the end, relocking this slice. When this display chest is emptied, this trapdoor depowers. However, we don't want the state change from filling the display chest to be directly transferred to this dropper latch, which would repower the dropper line. Thus, we send two signals through these two observer lines with a 1 game tick offset to depower and repower this torch, which switches the state of this dropper latch. As we have global locking on the top box display, there's a few other things we need to consider. Firstly, these hoppers need to be unlocked, and the dispenser needs to be depowered in order for the display to function. We do this globally, and the relocking will dispense the next box. Further, we need global boxes placement, which we have. We also have it on the bottom. In order to collect the empty boxes, whenever a box display is triggered, we unlock the collection hoppers and start this clock in order to dispense the empty box into a water stream for use elsewhere. In my opinion, this UI is the best possible. We have direct comparator readouts from each chest, allowing us to restock 54 items at a time. We also give the biggest viewing angle with all box displays and chests accessible from the display block here. Secondly, when walking through the hall, display blocks are easily visible. They're not up here, which is not great. The hall is also spacious, and we preserve a large viewing angle for the top boxes, despite having the fence gate in the way.